Okay, in this video, we are going to take a look at data types inside of MySQL. Kind of important discussion to have. We've been seeing them in use already, but I haven't purposely did not dive into them too deep because I felt it'd be a little too confusing. But it's getting to the point in the course where we do need to start talking about these different data types available inside of MySQL. MySQL does do a very good job of supporting the ANSI SQL standard data types. And just to recap, a data type is going to define what a column is inside the database, whether it is text, a number, a date. So that there's a number of different types in there, and they all have different properties to those types, and there's times that you want to use one over another. So in this video, we're going to go and explain exactly what those data types are. And we can break them down to about 5 categories there. We have numeric data types, so dealing with numbers. Date and time data types, that's going to be temporal data. String, that's going to be simple text. Spatial data types, and this deals with places and things like that. So I'll slide specifically on spatial data types. And then finally, we have JSON data types, and we're going to go through and look at each one of these closer in this video. So first up, we have the numeric data types. You can see here on the left column, I have the actual data type. And this is what you're going to be using in SQL, whether it's an integer or int. That's kind of like an alias. Now, this is going to take up 4 bytes inside the database. I'm going to explain that in just a minute if you don't understand what a byte is. Integer is going to be a simple integer, a number without decimals. You can see over here I have a min and max value, and this is an ANSI data type. Finally, we have tiny int, small int, medium int, and you can see these are different specifications of a number without any decimals, but it affects the maximum size. And when dealing with integers and the database restrictions, one thing you need to keep in mind is if you try to put in an integer that's too big, the database often will just truncate it and not tell you. So not a exactly desired behavior, a gotcha that can happen. And then we have a big int, and this is for a very big number. You can see there the min and max is with the scientific notation there. That means big number. And then we have floats and doubles. And these are floating points. And what's important here, it's kind of how computers work. If you're doing highly complex math and doing a lot of highly complex calculations, floating points, when you start getting into a lot of decimal places, it's not going to be exact. So you can get some variations there. Very small variations, but that is important to understand. It's kind of funny how computers work that way. But then we also have decimal and numeric. These are actually stored as a string inside the database. And this gives you a fixed decimal point. And also, this is where you're going to be doing like calculations with money. That's where you want to be using a decimal data type. Otherwise, you could run into unpredictable errors. And this isn't just a MySQL feature. Programming languages such as Java also run into this, and inexperienced people, when they start doing calculations with these values, you can start getting very small errors and not be able to trace back why, and it's because of this. So important to know. So as a rule of thumb, if you have a number and you want to pick out the integer, tiny, small, or medium, or big int, depending on how much room you need for that number, you don't want to grab a type that's too big for a number that's never going to get that big, because effectively you're just going to be wasting space in your database. So try to do as small as possible, but also be aware of the consequences of not doing it. And like I said, if you're dealing with financial calculations, definitely be using a decimal or numeric data type. Next up, we have date and time data types, or temporal data types, and these are pretty straightforward. So we have a date that is just a date value, no time component. This is an ANSI value. And then we have DateTime, and as far as I know, this is not an ANSI data type, but you can see when we go from date to DateTime, we get a large jump in the number of bytes that are consumed to store that value. Now, timestamp, the trick here, this also stores date and time, but it gets converted to UTC, so universal time. So basically the time zone gets lopped off. And what's going to happen underneath the covers is your database session is going to have a time zone. So it's going to get stored in UTC and then pulled out of the database and converted to your local time zone. So it's something to be aware of, because if you're working with another system, with a different time zone that's being registered with the database, you can get 2 different times out of the database, but that's because it's going to be converted to your session's time zone. Next up, we have time. This is a special value, so this can be time of day or an elapsed period of time. This is also an ANSI data type. And then a year. Year is pretty self-explanatory. MySQL can handle from 1901 to 2155, and I'm not quite sure why they did that, but that's from the MySQL documentation. I have a footnote here that MySQL 5.6.4 or greater can also store fractional seconds. So, and this is going to be on time, date time, and timestamp. This is an optional configuration and you do have to be on that level database or newer for this. And just be aware that if you do start storing fractional seconds, it is going to increase the storage requirements from 0 to 3 bytes, depending on the precision that you specify in the column definition. Now we've been talking about bytes. I also need to talk about character sets. So quick recap here. I don't know your level of familiarity with computers in general and how things are driven, but computers really drive off of binary information. So everything inside the computer is going to be a 1 or a 0, so on or off. So a bit is a binary value of 1 or 0, and then a byte is going to be a collection of 8 bits. So very important to recognize this. So you saw how I was talking about the storage requirements in bytes of these data values, and that's how much space it's going to take up on your hard drive or in memory for this to be stored. So important to understand, if you're dealing with a lot of data, your storage optimization becomes very, very important. I've seen a lot change in the last 20 years with computers, and we do have storage is very cheap now compared to what it was at one point in time. Now we can get a lot of space, but still a concern on getting very large data sets in the database. You do still want to be optimal when you're storing things and be aware of what's going on underneath the covers. So I started the slide talking about character sets, and this is how these bits become bytes and how those bytes become something like a letter. So the original character set was ASCII. Some people say ASCII 2, but I've always called it ASCII, which stands for American Standard Code for Information Exchange. This is like one of the first character sets out there. It was limited to 128 characters, mostly letters, numbers, and common punctuation. The problem with ASCII is that it was only 128 characters, so this did not work for international languages, things where you have special characters like the Russian language, which has a lot of crazy characters in it compared to what this is in English. So we started coming up with different character sets. There's a lot of different character sets out there. This is a very complex and confusing topic, but the most popular one out there is probably UTF-8. This is used for email and also the web. It's the number one character set used on the web. Depending on the character, it is 1 to 4 bytes long, and it gives us 1,100,012 and 64 characters. So a very large character set, very robust character set. So, and this handles all the international requirements. If you remember when people started texting, if you had an iPhone and you're texting with somebody with an Android, and they sent you a little emoji character, sometimes it'd come up as a question mark or blank or something like that. That's because the two phones are using different character sets. And those little emojis are not always translated between the two. So just an example of where things can go wrong on character sets. Now, I bring that up, got into character sets because we need to talk to them about when we're doing storing string data types. So first up is character, C-H-A-R. And this is going to be stored in the database. So you're going to declare a character data type of like char 5 there in my example. And what's important to remember is if you do that and you store a 3-letter word like foo into that, what's going to happen is MySQL is going to store foo space in the database. And then when it retrieves it out of the database, it's going to lop off the trailing spaces. Now, varchar is similar, but the key characteristics of varchar is that it's going to be a variable length string that you can store in the database. So you can store a word or a group of words into the database in a varchar, and it's not restricted to that. Well, you get a little storage optimization there because you do have the length of the varchar that you're putting in there. but then you get a +1. So this is good for where you have varying length stuff. And varchar is very, very common to use. Now we have binary and var binary. And these are like char and varchar, but one is fixed length and one is variable length. The key to the binary values is these are going to be stored as a binary character set. So when we set up the database is going to have a default character set. We have not had to do that so far in the course because there are defaults set up for that, but we can override those. Sometimes you need to, sometimes you don't. But what's important to remember here is the difference between the char and the varchar. These are going to be stored with the character set information, where the binary stuff is going to be stored without a character set. It's going to be stored with a character set of binary. Next up is we have a blob. And then this is a binary large object. So again, this is going to be stored as binary. You can store text in there. I will also use this to store images inside the database. So if I have a web application, you can store the binary encoding of an image file into the database. Text is like a blob, but this is a non-binary string. So this is going to be similar to a char or varchar, and probably closer to a varchar because this is for a very large text operation. Next up is we have an enum or an enumeration, and this is going to be a collection of string literals. So I got an example here. You would literally have red, blue, and green, and then that column, that database column, would be restricted to one of those values. Now, a set, the very last one that we have here to talk about, this is very similar to an enum, but it is string values, but that column can have one or more values in that. So an enum is one and only one from those defined values, where a set can have more than one. So I personally have never used a set. I've never had a need for it, but enumerations are very handy. So these are very, very handy things to have inside the database to set up a list of values that you want. Next, we have spatial data types. This first bullet point, this is right out of the MySQL documentation. The Open Geospatial Consortium is an international consortium of more than 250 companies, agencies, and universities participating in the public development of available conceptual solutions that can be useful with all kinds of applications that manage spatial data. So that's kind of a mouthful there. Basically, spatial data is going to be defining points on a map, is a good way to think of it. So if you remember basic navigation, you have longitude, latitude, and latitude, and different things. So this is a very complex piece of information here. And what it can be used for is doing searches inside the database. If you have like postal codes and you want to find a store near you, you can run queries using geospatial features. This is pretty niche, not widely used with MySQL. So at this time, I'm not going to be covering this inside the course, but I want you to be aware of the spatial data types. But I know it's out there. I just don't know a lot of people using it. Next up, we have the JSON data type. So JSON stands for JavaScript Object Notation. So this is a complex structured document which contains properties and values. And I do have an example to show you on the next slide here. And the storage of a JSON document is going to be very similar to a blob or text data type as far as how much is going to be consumed inside the database. What's important to remember is that MySQL is going to take the JSON that you're giving it and convert it to an internal format that's internal to MySQL. But this is going to be optimized for storage and searching and any operations that the database has to do on it. But because it gets converted and then brought back out, some of the formatting, if you have spacing in the JSON document, that could change. The ordering of properties could change, and that this is something that you really shouldn't be depending on having properties in a specific order when working with JSON anyway. But something to be aware of when you're dealing with JSON. And then MySQL also supports searching of JSON document properties, so you can go in and search the database for a specific field in a JSON document. And then MySQL also allows you to update a portion of a JSON document, so you can go in and update a JSON property without having to replace the entire JSON document. So a nice feature of this. And at this point in time, I'm not planning on covering the JSON data type inside of MySQL in the course. If there's demand for it, I will. I know it's a capability of MySQL, but I personally have never used it. I work with JSON all the time, but Usually in my programming, when I'm programming in Java, I'm going to read in the JavaScript or the JSON object, read it into Java, get the properties I want, and store those into the database. So it's pretty rare that I would store an actual JSON document into the database. But that's just the use cases that I've had. If there's demand in the course, I may add that in at a future date. Now here's a JSON example. This is just, I literally Googled JSON example, and this is one of the examples that I found. This is a well-structured JSON document. You can see there we have a widget at the top line, colon, and then we have a widget object. So we have debug on, window, and then another property would be image, and you can see the properties of the image object inside the JSON object. So this is just a structure. This is there's a syntax to it, and this is what MySQL will store in the database, and you can go in and search on, you could do, give me all the documents inside the database that have a widget.image.name of sun1. So you could do something like that and request all documents where it has that image property of name set to sun1. So that these are some of the capabilities that you can do inside of MySQL. Again, I think this is still fairly niche with MySQL. I'm not going to get into JSON too much, but I wanted you to be aware of it. And if you do have a need for it, definitely let me know, and I may expand upon the JSON content for the MySQL course.